session of the day, lessons from Canada's first panelized multi-family retrofit. And I'm pleased to be able to introduce Peter Amerongen, Managing Partner of Butterwick Projects. Thank you, Peter.
Thanks, Michaela. So I've been building stuff for about 20 years. I got interested in energy efficiency about the same time that the Sundance Housing Co-op was being built in 1977 at a talk by Harold Orr. In 2006, I kind of woke up to climate change and was part of the team that built one of Canada's first net zero energy buildings, the Riverdale Net Zero Project, which is in the lower right of your screen. And I lived in the co-op for about 20 years and then built myself a house that's also in the bottom of the screen with a round roof. I hate commuting, so the Sundance Co-op is a 15 building, 59 unit townhouse complex. It's extremely well run by, self-managed by volunteer co-op members who take a really long view. When the co-op was being built in the 70s, the building code was just about to change from 2x4 to 2x6. And they opted to go for 2x6 walls and gave up closet doors to be able to afford it. They also started then one of the first recycling programs in Canada. They're the perfect partners for this kind of pioneering work. Their mortgage and their lease with the City of Edmonton were both coming up for renewal, and they knew this would be a good time to look after some maintenance backlog and some repairs that were on the horizon and any upgrades that would be needed for the foreseeable future, including preparing the buildings for a net zero energy future and higher carbon taxes and that sort of thing. So they hired Stuart Fix from Renew Engineering to do a building condition assessment and energy modeling to see what energy upgrades would make sense. He hired me to help with the building condition assessment, and Dave Butterwick to do costing, and we're all now partners in this venture. So the preliminary costing came in at about $5.4 million for the deep energy retrofit version. And while the co-op was considering their next steps, we learned about the possibility of some R&D funding from Amerongen, and so we proposed that we would do apply the Dutch energy sprung approach to the 59 townhouses, and we were successful. And the $2.5 million from Amerongen made their financial decision way easier. There was never any doubt. So we're grateful as heck to Amerongen for this opportunity. And I can tell you, we're earning our keep here. They're getting their money's worth. We're starting with some pretty complex buildings. They're especially compared to what they're doing in the Netherlands. I got a tour of some energy sprung buildings just before we started this project, and I showed my tour guide these photos. I said, Simon, what would you do with those tight jogs, the cantilevers, the porches, doors that are too close to the corner to install a panel, all the mature landscaping? And he smiled and said, oh, for us, that would be a no-go. So we kind of knew we had our work cut out for us. So we did a pilot project on the first 2 units in 2019 to kind of test drive our preliminary concepts. And we came away with a list, no kidding, 240 things that we could do better, and things we need to improve, mistakes we needed to avoid, and then started up again in November of last year, and have been learning a whole bunch more. We had no idea really. I mean, it sort of stands to reason, but the benefits of doing this 15 building project one at a time. we're behind, but we're getting faster, and slowly I think we're catching up. So we start with digital capture, just like they're doing in Holland. It's a LiDAR scan. The surveyor did 55 scans in total, and then calibrated them with total station coordinates and registered them all together into one ginormous 176 gigabyte file, which he then clipped out. Individual buildings and sent us more manageable 5 to 10 gigabyte files to work with. And then we import that into a SketchUp app called Undet inside of SketchUp, extract the best fit wall planes. And the extracted walls, just like the real walls, aren't plumb, square, or level. So they need to be judiciously fudged to be orthogonal for the drawing and manufacturing process. When we have all the walls, we install window and door elements on them and anything else we need, and slide them around on this fuzzy point cloud to get the best fit. Knowing the consequences of making a mistake are catastrophic practically. And then we divide the walls into panels, draw each wall and draw each panel, and each panel takes 4 drawings, framing drawings with every stud, every header, all the lift points and the cellulose fill holes, the weather-resistant barrier that's also our airtight layer, the detailing of that, and what siding goes on and what doesn't, which window goes in, it's a ton of drawings. We've got 20 to 30 sheets per building of just panel drawings, and then another 15 sheets of standard panel details, and a second set of 6 to 10 sheets per building for the on-site work, and about another 15 of standard site details. So for all the kind of coolness and horsepower of the computing tools, there's a huge amount of work that requires judgment and is really exacting. It was a bit of a shock, not to mention expensive. So while the panels are being built, we use a hydrovac truck to essentially suck a slot as small as we can get around the building and still get the insulation in to do the bulk of the foundation. And then we build a pressure-treated wood foundation box that we hang off a ledger, engineered to carry the panel weight, any additional loads like porches and decks and that kind of thing that need to go on it, and also complete the insulation and air tightness at that location. And the panels themselves are lightly framed 2x4, just enough framing and structure to handle the weight of the siding and the windows, and also the stresses of transportation and handling. So they're and then the big day, basically, we're the installing the panels is quite exciting, and the building transforms almost immediately. Lots of anxiety about whether the doors and windows are going to fit. The consequences of a mistake are huge. We've got a 6-person crew and a crane on site there, and we would be stopped dead in our tracks if they don't fit. Very hard to move the windows in these finished panels. We've got a 10 millimeter allowance to be able to slide the windows back and forth to get the best fit on the existing windows and doors. And I'm ecstatic to announce that we're we've hardly used that. These things are lining up perfectly. It was just a huge relief. High fives and whoops and hollers, and would have been hugs if wasn't for COVID. But anyway, so that part of the building that part of the process is going very well. We're excited to get our next set of panels on Tuesday. So once the panels are up, we blow the gap full of cellulose. It gives us about an R28, and then we stitch together the water-resistant barrier, which is also very vapor open, besides being airtight and watertight. Airtightness is one of the biggest single sources of heat loss in these buildings. We tested a number of them, and they are roughly at 3.5 to 4 air changes an hour. After we've sealed up the building, we're at about 0.6, just about passive house territory. And we've also we do that with the rain screen battens that you see in the photo there. That they sort of do a double function of sealing up the WRB and also giving us drainage in case of any minor leakage behind the siding. The siding is fiber cement from James Hardie, very durable. So, one of the parts of the value proposition is that these buildings shouldn't need much work in the next other than perhaps a coat of paint, over the next 40 or 50 years. And we use Harold Orr's chainsaw retrofit approach on the roof. We saw off the overhang, wrap it all in poly that gets sealed to the water-resistant barrier on the panels, and then put scissor truss structure over top that it gives us room for an R50 cellulose insulation, and really results in an envelope that's about what we would do for a net zero energy new building. And having reduced the heating loads by about 70%, it makes sense to electrify even in Alberta. Our grid is getting cleaner. One of the upsides is that we avoid about $38,000 in fixed monthly charges by abandoning 59 gas meters. We're using cold climate air source heat pumps and air source heat pump water heaters inside the building, getting about a 200% efficiency of COP of 2 on the heating, and about 1.8 on the hot water, and these are seasonably effective in our cold climate. So the plan is to use 100% renewable energy, but in order to electrify here, the original construction just had 60 amp service to each of the units, and that was never going to be enough to provide this extra heating and hot water load, especially at minus 30 C when the heat pumps are operating at a very low efficiency. So we had to completely redo the electrical system with a new 3-phase system with underground directional drilling, and we're setting the co-op up actually with our own mini utility, and we had a terrifying encounter with demand charges, which is something that the whole drive to electrification needs to consider. The size of meter that we needed for the entire site put us in a utility rate class that would have attracted a demand charge year-round at 48 cents a kilowatt hour based on 90% of our worst month, which would be a cold winter month when the heating system is at its lowest efficiency and the load is the biggest. So that would have been just crippling. It would have wiped out any savings from the whole project. In fact, they would have been paying a lot more for energy than they are now. So we, in a sort of a mad scramble to figure out what to do, and with the connivance of the utility to some degree, we reconfigured our system as 8 solar co-ops that put us in a rate class that was much closer, in fact, just about the same as typical residential service. So, we dodged that bullet, but this is a major hurdle that we're going to face, and we faced it on multifamily buildings, net zero multifamily buildings that we're working on now. It's a big issue. These are real costs to the utility to be able to provide that level of service, that amount of demand for a few days of the year. It's something we're going to need to figure out. So the co-op's committed to basically zero carbon. They're installing a 350 kilowatt solar array that's modeled to produce about 75% of their total annual energy needs, and the remainder will be purchased from off-site renewables, making the complex effectively net zero. One of the big learnings for us has been the people part of the job, and we always consider it job number one to make life better for everybody who's going to live in our buildings. In the future, with warmer, healthier, more comfortable houses. I mean, these buildings are beautiful. The color scheme is lovely. They're crisp and new, and we've also managed some little enhancements along the way. We're adding window seats in the living rooms. We're adding skylights in the porch roofs so that the kitchens are a lot brighter than they used to be. Every window becomes a nice deep windowsill, and members are getting the opportunity to enlarge or add new windows if they like. But the more the startling learning was how important it is to try to provide, to minimize the short-term pain that comes with living through a construction site. There was a vast majority of the co-op members voted for this, but there were a few that were not so convinced, and we found we've had to refine our operations and procedures to minimize the time and disruption that happens in people's houses. The co-op has a fabulous committee of hardworking volunteers that we work with to manage expectations and solve the inevitable problems that arise on a project like this. They've also hired Communitas, an agency with almost 50 years of experience in the co-op sector, to manage the non-construction part of the project, look after the financing and that kind of thing. And we are deeply grateful to both of them. This would not be possible without them. All of this is being documented and will be part of our report. So the hard part, costs. These are, I'm not going to go through these in detail, but these are budget numbers, and we're struggling to meet this budget. We're behind. We are getting a little faster and narrowing the gap, but it seems like the cost savings are always harder to find than the cost increases. We're grateful to Amerongen, who bailed us out from the lumber spike, the first lumber spike, but now they've even gone higher. As I look at these numbers, I'm not super hopeful that we're going to be able to drive them down dramatically in the future in the ways that we've sort of been hopefully talking about at this conference. I just don't see where the big savings are going to come from. The panel costs are only 25% of the project, Of that, almost half is the window cost and the on-site insulation, and even the remaining part is largely materials. Like, our panel partners will be able to get more efficient and do better with some mechanization, but we're not gonna have this. We're not gonna knock off 30-40%. It's an ongoing problem. I think we're going to need to find more money, or we're in trouble. And ultimately, the energy savings don't pay for it. The maintenance and catch up and avoidance helps a lot. In this case, obviously, the Enercan contribution is very significant, and the co-op also got a favorable lease rate on the city of Edmonton renewed their lease at a nice rate to 2099, and that helped the financing portion as well. So, where do we go from here? So, one thing we can't do that is the kind of piecemeal, partial retrofits that are being funded by governments and utilities in incentive programs. And this building is a good example. This is one of the buildings we're retrofitting. A few years ago, the members in that building convinced the co-op to replace the siding. It was getting pretty tatty, and it got done with adding like a half an inch of some goofy, hard to, I think it was radiant barrier snake oil insulation. The windows weren't touched. Nothing was done about air tightness. None of the things that you do in a comprehensive, well-planned renovation that really. So now that stuff's in the way, and we would love to have that money to put into this project. So, and I get people wanting to do this sort of thing to their house, coming to me all the time. They're early adopters, well-meaning. They've already taken advantage of the programs. They've got more insulation in the attic, which is a barrier to us to make it airtight. They've replaced the windows with mediocre windows, and these half measures will lock in the remaining emissions from those buildings for generations and likely prevent them from ever being zero carbon. And they've lost any of the efficiencies that come from a comprehensive, well-planned and executed retrofit. This is not to say it has to be done all at once. Some measures can be grouped and done in batches, but they have to be well planned with net zero as an end goal. And in some cases, like in newer buildings, the solution set will be different and not go this far, but they need to be planned with net zero as the end goal. And so we're struggling, and I don't think this is because we don't have the right people or the right approach. I think this is hard because it's hard. I just want to tell you a little bit about our team. We're lean, well-rounded, highly integrated, IPD as all get out. We're smart builders. We've got passive house experience, really pragmatic and cost-conscious, small, low overhead. We've got in-house design, mechanical engineering, energy modeling, electrical engineering, and we can do our own structural calcs. We're building science nerds from top to bottom, driven to innovate. Justin Corso in the middle there, our site manager, is the smartest, most driven carpenter I've ever worked with in my 50 years in the biz. We have an amazing crew. They're relentless in trying to find better, faster ways to get this done. And every building is going a little faster and better. These guys can't wait to start the next building to try out the improvements they came up with on the last one. So our biggest problem is how to clone them. We all share a real fear of climate change and are on a mission to do our part, and are optimistic that we're in the vanguard of a bold new industry. So how do we scale this? Ralph Tori asked me the other day, what would we do if we had 5,000 units? And his question kind of shook me out of my kid with a crazy dream state. And I was thinking kind of, if we build it, if we solve these problems, they will come. But we start on a subset of buildings with good bones, good locations, simple geometry, with exteriors that are in really bad shape, with big energy upsides, and we use those to build industry capacity, get faster, better, and cheaper. And by the time we get these done, we'll have the chops and hopefully the political will to tackle the hard ones. And I still think that's right, but it isn't going to be anywhere near fast enough to do the millions we've got to do. And one of the problems is that basically, this is ultimately very specialized renovation work with all that means. Most of it happens on site. Gleaming factories are only going to take us so far. It's not rocket science, but it's definitely a different kind of construction that requires skilled and motivated workers with good problem-solving skills that are hard to teach in a classroom. Systems and better products will help, but we need workers, all kinds of them, who understand airtightness, building durability, and that can do interior and exterior finishing and are polite and respectful in working in people's houses. The range of situations that these workers will confront is large, but it's limited enough that we could probably catalog them in a great big manual, kind of like CMHC's framing manual. That's one concrete thing we could do, but we also need designers for the new exteriors, architectural technologists who can do digital capture, energy modelers who can spin the dials and optimize envelope solutions. And then there's feasibility planning, design, financing. And so we've been thinking about this stuff, and we think what we need is I'm not going to give these next few slides the time I think they deserve, just because I'd like to see some time for discussion. These are complicated projects with the potential to waste all kinds of money in planning, design, and project development. And after working on consulting on a bunch of them and fielding hopeful inquiries and seeing lots of mistakes, I really think we need a clear roadmap, which is something that we're working towards developing. This would guide owners of different building types, ages, conditions, through a logical series of steps that would help them get started and get it done as efficiently as possible, and right off the bat, find out if they can afford it. So we're working to develop that. We're also working on a 3-house pilot. By the numbers, GHGs from single-family houses are huge and going to be a lot harder to tackle. We think that the system we've developed for Sundance will work well on single-family, better than the stick-by-stick approach that we've done. We've done quite a number of stick-by-stick ones, and we think we can improve on that. We're starting construction on a 3-house pilot this fall. Our biggest barrier is personnel. We're starting to train a second crew on the Sundance project. And then one other thing that is very cool and hopeful that's part of this 3-house project is we're supporting a brilliant computing science grad student who's come up with a drone-based photogrammetry system that's knocking it out of the park for the digital capture. It's less expensive and very, very reliable. We've done all 3 of these pilot houses, and the time reduction is huge. It's very very cool. And so in the process, and part of both of these projects is a commitment to outreach, and with the funders, with Amerongen and also SSRIA. So we started a Retrofit Canada, that we'll use to share these lessons from these and other projects across the country, and host the Retrofit Roadmap and try to connect people with the resources they need to retrofit Canada. Our hope is to be able to find the resources to continue Retrofit Canada after we complete these two projects. And with that, thanks very much for your attention, and I'd love to have some discussion.
Peter, thank you. That was a fascinating session. We do have a couple of questions. Shall I read them out to you?
Yes, please.
How do you reconcile the need to not do half measures and the cost challenges if you're talking about with a full net zero retrofit? If net zero compatible half measures are the answer, what are some examples of those?
Okay, so an example would be my own house, which I built as an R2000 house in about 20 years ago. And there's a much smaller energy upside. I could get our house to net zero by installing a geothermal system and electrifying and changing the glass in my windows, which have really good frames. And I think there's a whole class of newer houses that are closer where that'll make sense, where and particularly in warmer climates with better fuel sources. Otherwise, I think in our region anyway, we're going to need more of the full deep energy retrofit type approaches than in, say, the Lower Mainland and places where renewable energy is abundant.
And then I have another question here from Jason Ains. Do you have any comparison between the panel approach versus taking the building envelope down to the studs and completing the finishing necessary? And then he's written, I understand the impact on owners in that alternative, but I'm wondering about the difference.
We think that this approach, the panelized approach, particularly on single family, will be a little bit cheaper, not a lot, but that the speed, the capacity increase of our crews and the smaller disruption will make up the big difference. So it'll shorten the project up by a lot. So that would be the main. Shortening the project and minimizing disruption will be the main benefits. And then, we're definitely going to try as we systematize it more to drive that cost down. But that's the main savings.
Excellent. Emma Norton writes, hi Peter, thanks so much for the presentation. I work with Laurie and Nick on Recover in Halifax. Your predictions about costs are a bit disheartening. We felt we could reduce costs if we can find ways to automate designing and feasibility studies, plus by aggregating projects and achieving economies of scale. Can you speak to that a bit?
Well, I think those are all possibilities. Like but when you break the cost down, as I said, it's ultimately a renovation project, and a lot of the work ends up getting on site, and there are inherent in any renovation, dealing around with existing penetrations of services. In our case, putting in new services, there are always a lot of fiddly little things that have to be done, and it just doesn't. We could look at different panel approaches. In the Netherlands, they've got the panels to be more like Lego bricks that are completely sealed. They don't have to. They have the insulation in them. They're quite a bit more expensive than ours. They definitely do less work on site on the air sealing and applying exterior finishes or finishing the exterior finishes. But I don't think these are kind of order of magnitude savings. I think ultimately we need to figure out a way to finance it, and I'm disheartened too. I look hopefully at the policy and financing people to see whether we can whether we can make this work. And again, I think we start with the buildings with the biggest upside and the biggest maintenance backlog. Like it's a giant leap of faith, but I don't see any alternative. Yeah.
Another question here, is post-occupancy evaluation being done in these projects? If so, how are the results looking based on the expected energy performance?
We've only done 4 buildings so far, and the electrical upgrade wasn't complete on the pilot building, so it's still running on natural gas, and with an open B vent. We will do post occupancy measurements once, and it will be very easy because the utility system that we have put in will be using we'll have access to all the usage data for each unit, so it'll be easy to aggregate that. But we haven't started to do that yet.
Ryder Petch asks, any opportunities to use innovative alternate carbon storing products that are also structural support, like hemp blocks, to avoid escalating lumber costs?
Well, hemp is a possibility. We've started with what we think is the easiest wood frame construction. Until the price went through the roof. Hopefully that's temporary. And we're comfortable in that this is a pretty low carbon solution to start with. There's wood fiber in the fiber cement. There's a small amount of cement, and clearly we're using cellulose, which is the lowest. It's actually a carbon positive insulation. We're using EPS insulation, which on the foundation, which is minimal or low global warming impact. So I don't know. I think the carbon savings that we're leaving on the table are probably relatively small. I can't hear you. I'm sorry.
Apologies, I muted myself. One last question from Matthew Sharp. Thanks for your honesty around costs. What was the project payback with and without the incentives?
The costs have I don't have it in years. We're still kind of crunching those numbers. The Amerongen grant and the favorable lease from the city has resulted in them not having to raise their housing charge. So basically, the combination of their lower energy bills and their lower maintenance costs are enough to break even on the post-subsidized costs.
And then we have one last question and 1 more minute to go. Do you see any role opportunities for ESCOs in this approach, perhaps after aggregation?
I had to Google what that meant, so I'm not sure. And we're builders. We're just starting to explore the ramping this up on bigger projects. I expect there is a role. With the margins so tight, it has to be anybody who's involved, any consultants involved in this process have to be working on a shoestring budget. But I ultimately think it sort of depends on first developing a good business case for it.
Peter, thank you. That was a fabulous session. Great to see so many questions. Thank you for taking part. And audience will be back in 20 minutes exactly for the final session of the day. Thank you.
Thank you. This has been a really enlightening conference for me. Thank you.
We appreciate you attending. Take care. Thank you. Session of the day, lessons from Canada's first panelized multi-family retrofit.